All right, so yeah, this is the final lesson of the course. And yeah, I'm just as happy as you guys are about this. So anyways, yeah, so this last lesson is on something called binomial probabilities or binomial experiments. All right, so first thing I'm gonna do here is just explain what a binomial experiment is. Okay, so binomial experiment is basically when you do an experiment with a fixed number of trials. Okay, so and there's only two possible outcomes for each trial. Either it's going to be a success or a failure. Okay, so this is kind of abstract, but I think it'll probably get a little bit better understanding if I listed a few examples here. Okay, so for example, one binomial experiment would be, let's say you flip a coin 10 times, right? And so the number of trials, each flip of the coin would be considered a trial. And then, so let's say you do flip a coin 10 times, okay? So that's the fixed number of trials. There's only two possible outcomes, right? You could either get a heads or you could get tails, right? So what you would be doing is you'd be calculating, say, one question would be like, calculate the probability of getting 3 heads if you flip a coin 10 times. Okay, so that would be a binomial experiment. Okay, another example would be, let's say you roll a die 17 times. Right now, I'm just coming up these numbers here. This number of times is quite random. Right, it's just basically you're just repeating this, repeating these trials. All right, and let's say you're counting the number of times a 4 comes up compared to not a 4 coming up. Right, so yeah, so even when you roll a die, there's 6 possibilities on a regular die. But when it comes to binomial experiments, you're counting the number of successes versus failures, which means I want to know, how many times does a 4 come up compared to not coming up, if that makes sense. Okay, so those would be your 2 possibilities. Now, another example would be, let's say you have a multiple choice test, and the test has 32 questions. Again, this number 32 is just a little bit, just a random, it's part of the example, but however many questions, right? That would be the number of trials you'd consider. And let's say you were to guess on the test, and either you're going to get the answer right or you're going to get the answer wrong. Okay, so that would be your success and failure, right? Even though for each question you might have like 5 options, if you consider the outcomes as success and failure, there's only 2 possibilities. Either you're going to get the question right or you're going to get the question wrong. Okay, cool. So like a question that would involve multiple choices, like, yeah, so let's say you have a test with 32 questions. What's the probability of getting exactly 20 right? And you can actually calculate that probability if you were to guess on each one of those questions. Okay, cool. So there's a formula associated with it. What you'll notice is in the formula here, the n choose x. This comes from the combinations. Oops, I can't highlight that. Combinations unit. All right, so this is we n choose x. All right, so it comes back into play. P is the probability of success per trial, and Q is the probability of failure. Okay. N is the number of trials, and X is the number of successes. All right. So yeah. So right now this formula probably looks kind of abstract and so on, but I think you get a better understanding once we go through the example. Okay. So I'm going to leave that formula there, and this is my example. All right, so let's say you have a multiple choice quiz that has 5 questions, and each question has 4 choices. Okay, and only one of which is correct. All questions are answered by guessing, and let's determine the probability of guessing. Exactly 3 correct answers. Okay, so if I was to break this down, I'm going to be using this formula. Just get my pen. All right, so I'm going to be using this formula. N choose. Let me just write it again. So N choose X. P to the X. So you're multiplying these two. P to the X times Q to the N minus X. All right. So what I want to know is what am I going to plug in for each one of these variables. Right. So N is the number of trials. Okay. So if this quiz has 5 questions, you're going to be guessing 5 times. So therefore N is 5. Right. And each question has 4 choices. Okay, so that would come into play with the probabilities. In terms of the X, I want to know what's the probability of getting exactly 3 correct answers. So my X would be 3, the number of successes. All right. P in this case is the probability of success. So if there's 4 choices, the probability, if you just guess, would be 1 in 4. So 1 out of 4, which we can actually write as a decimal, which is 0.25. Right, you have a 25% chance of success for each question. All right, and let me just scroll this down a bit. And Q would be the probability of failure. So if I'm going, my probability of success is 1 out of 4. The probability of failure would be 3 out of 4. Okay, so I have a 75% chance of getting the question wrong if I was to guess. All right, so if I was to sub these numbers in into the formula, right, n is 5, so this would be 5 choose x is 3. Then I have 0.25 to the third power, which is x, and then 0.75 to the n minus x, 5 minus 3. Okay. All right, so let's work this out here. Now with my calculator on the computer, I don't have the choose thing, so I have to use my calculator off to the side here. So if you got your calculator handy, I would suggest that you follow along and punch these in as I go along too. All right, so 5 choose 3 is 10. All right, now 0.25 cubed, or to the third power, is, okay, it's a fairly long decimal, but I'll still write that down. 0.01562. And then 0.75. Now I'm just going to do this quick. So 5 minus 3 is actually 2. So I'm just going to cross that out and just write 2 there. So I'm doing 0.75 squared, which is 0.5625. Okay. So if I multiply these 3 numbers together, all right, so I get 0.087, or I'll just round it to 88. All right, so in other words, you have an 8.8% chance of getting exactly 3 correct answers if you were to guess. All right, cool. So again, yeah, so n is the number of trials, x is the number of successes that you're trying to find, q is the probability of success for each trial, q is the probability of failure for each trial. So you plug that in, and so the probability of getting 3 out of 5 right, if you were to just guess on for 4 choices for 5 questions, is 8.8%. Cool. All right, so let's go on to the next one here. This time, we want at least 4 correct answers. Okay. So whenever you see the word at least, this will be in terms of cases. Okay. So if I want to get at least 4 correct answers, this is the same as saying probability of getting 4 right, or the probability of getting 5 right. Okay, so since there were only 5 questions. Okay, so yeah, so same thing here, just as we were doing before, is that we're going to have to separate this up into cases, and we're going to add these 2 probabilities together. Okay, so again, n is 5, p was 0.25, and q is 0.75. All right, so and as well, I don't want to keep scrolling back and forth. So what I'm going to do is just write the formula up here on the side here. So n choose x, p to the x, q to the n minus x. All right. Cool. So if I sub these values in, n is 5. It's going to be 5 choose, in this case 4, 0.25 to the 4th power, and 0.75. Oops, I'm just going to erase that plus sign here. 0.75 to the 5 minus 4, which is 1 power. Or, so plus 5 choose, x is 5, 0.25 to the 5th power, 0.75 to the 5 minus 5, which is 0 power. Okay. So this is going to equal, Now what I'm going to do here is I'm going to probably just punch all this in at once. So 5 choose 4 is 5, I think. Should be. Yeah, so that's 5. 5 times 0.25 to the fourth times 0.75. All right, yeah, you know what, that's fairly lengthy. Yeah, let's just write that down. Sure. Oops. Okay, so this whole thing turned out to being 0.0146 dot. All right, I'm just going to go to that many decimal places. All right, now 5 choose 5 is 1. I know that. 0.25 to the 5th power is 0.0000976 dot. Okay, so if I add those two together, 0.0146, we get a total of 0.0156. All right, so in other words, that would be 1.56% probability. Okay, so whenever you spell the word at least, and just be aware that you're going to be splitting it up into cases. All right, so in this case, you'd have to add these two probabilities together. All right, cool. So let's do this one here. This time we want at least 2 correct answers. All right, so if I want at least 2 correct answers, this would be probability of 2, 4, 3, or 4, or 5. Now, this here, I don't really want to be doing all 4 of these and adding them all up. So what I can do is, if you guys remember that trick from the last couple lessons where we do something called the complement. If I want at least 2 correct answers, right, it's going to be the same as 100% minus the probability of getting none right or getting 1 right. Right. So if I calculate this probability and then subtract it from 100%, it should give me the probability that I'm looking for. Right. So I'd rather do 2 of these instead of 4. Okay. So again, the formula here was n choose x, p to the x, q to the n minus x. All right. So yeah, don't ask me why I have this thing memorized. I just do. Okay. All right. So let's figure this out here. All right, so the probability. So this is the method I'm going to use here, okay, to get the answer. So I'm going to do these separately. So probability of 0 getting none right, all right, is, again, actually lower the number of questions. So n was 5. P is 0.25. Okay, probability of getting a question right is 0.25. Q, which is probably getting the question wrong, is 0.75. All right, so if I plug in that here, like what do I got here? 5 choose 0, 0.25 to the 0 power times 0.75 to the 5th power. Okay, so this is going to equal, if I punch that in, just, okay, 5 choose 0 is 1 times 1, so 1 times 1. So this stuff here is basically just 1. We're going to just cancel that out. 0.75 to the 5th power. No, 0.75 to the 5th power is 0.237. Okay, so I'm just going to go to 3 decimal places. I'm going to do the same as getting the probability of getting just 1 right. Okay, so that would be 5 choose 1, 0.25 to the 1st power, 0.75 to the 4th power. All right, so this one here, I'm going to punch all that in. 0.75 to the 4th is 0.39. I'm going to round that to 6. All right. So the probability of getting either 0 or 1 right is when we add these together. So if I tally that up, 237 plus 0.396. All right, so 0.633. Okay, so yeah, so you have a 63.3% chance of getting none right or one right if you were to guess all of them, which is more than 50% of the time. All right, so therefore at least 2 correct answers. So we'll scroll that down. All right, so the probability, actually, I'll do it over here. Probability of at least 2 is basically I'm going to take the complement. So 100% minus getting 0 or 1 right. Okay, so if I subtract that from 1, that's 0.367 or 36.7%. Okay, so as far as, yeah, so for some of these questions, it might be easier and less tedious to do the complement, what I did in this last example, part C. All right, so rather than adding up these 4 separate ones, I did the 0 and 1 and subtracted it from 100%, all right, because it's the opposite. All right, so yeah, so if you were to do these separately, the probability of getting 2 right, then 3, then 4, then 5, add them all up, we will get the same amount here, 36.7%. Cool. All right, so for practice, these are the questions that you want to try. So 11, 12, 15, 16, 17 off that worksheet. So let me just open that up. There's this one here. Yeah, so the first half of this worksheet was all that conditional probability stuff from last lesson. And then so we want to do, yeah, so 11, 12. So starting from here. So those numbers that I listed, all right. Cool, and the answers again are at the bottom here to check. All right, guys, cool. So that's the lesson for today. Ciao.